and applying analytics to your business. I'm not an expert in everyone's business. Like, apparently you have people from finance and tourism, and I'm not an expert in really any specific industry, but I'm pretty good at thinking about data and how to apply it to your business. My role is chief data scientist at an analytics company called LKNA14. So I work with usually developers and technologists, but also product managers and executives at medium to some large companies, and I help them figure out what business problems they're trying to solve, what data they can collect to help them solve that problem. And I've been doing that for about 2 years now. Before that, I worked at a consultancy called Accenture, and I did really large-scale SAP implementations. So that was kind of a totally different world, but now I do data stuff every day, and I've learned a lot along the way, so I wanted to share some of the things that I've learned and hopefully give you some things that you can apply to your work. So my talk is a reduced version of a 2-hour class that I teach for companies. Hopefully you'll get some value out of this trimmed down version, but here's how it goes. First, some context on what big data means. I know it's a buzzword that's probably annoying everyone at this point. What does data science mean? How to think about applying data science to your organization. And then I want to touch on a technical concept called event data, which is what runs a lot of big data analysis. But it's actually a very, very simple concept. And then I want to teach you how to use event data and how to apply like really common analytics methods. 99% of data science is just really simple math, and that's one of the things that I want to convey in the talk. So, first, some context on big data and analytics. There was this trend in the 90s where every company kind of became a software company. Everyone had to build software for manufacturing or a website. Everyone had to start hiring developers, and that trend is kind of already come and gone. And now there's a new trend where all these companies have software, they have internet-connected devices or websites, mobile apps, and they have an opportunity to collect lots of data and potentially learn about their markets or their consumers or even their own employees, and figure out, are people using the things that we build? So now there's a trend that every software company is becoming a data company, which is then leading to this thing where like data science is becoming a trend. And ridiculous articles are coming out like this Harvard Business Review one that says data scientist is the sexiest job of the 21st century, which is pretty good for me. And I was just fiddling around on Google Trends, which is pretty fun, and I typed in data science, and there's just this huge trend. If you type in something like analytics, that's flattening out. I think analytics generally seems to apply to like very specific things, like people think of like page view analytics or like mobile analytics. But data science is the trend that goes across your business and that people are starting to try to invest in now. So what does that even mean, data science or data scientist? I like this definition that I found on one of IBM's websites. What's different about a data science than a data analyst is that a data scientist thinks about the business and has business acumen. They have good communication skills and can think about how data applies to different business scenarios. And most importantly, they kind of can decide what problems to apply data thinking to. Versus a data analyst, someone will be like, hey, you're great with data. Will you go dig into our page view data and see what pages people are viewing most? A data scientist says, like, how do we take this data and what's the decision that we make for it? What's the next product that we build for our business based on what we find? So, I have some inspirational data stories which I hope you will enjoy. The first one is very, very old. It's about these astronomers from the 1800s. Brahe was fascinated with the stars, and every night he would write down the position of every star and every planet in the sky. And he did this for his entire career for 30 years, and then he died. Sad. But his assistant Kepler, he took all of this massive amount of data and he discovered the laws of planetary motion with that data. So Kepler was a data scientist, and I think Brahe was too. But I think it's really fascinating about how data science is not new. Data science is something that humans have been doing forever. Now we just have tools that allow us to capture massive amounts of data all the time. But there are some cases where it's really slow process and still pays off. We learn really interesting things about our planet, our world, our society. And Kepler is now like cemented as a genius in history. Brahe doesn't really get much credit, unfortunately. But another more modern data story is about the company LinkedIn. LinkedIn is known for having an amazing data science team. Early on, they hired someone to be a data scientist. I don't remember his name right now, but they've always invested in this. And one of the stories I really liked from LinkedIn was about this feature, which we've probably all used. Who has seen this? Like the people you may know on LinkedIn. It's really good, isn't it? Like you always know people in there. But the data scientists who came up with this idea could not convince the product team to put it in. They thought, people who are in business already know who they work with in business. Like if this isn't Facebook, we don't need to tell them who their friends are in business. And this data scientist was persistent, and they already had on LinkedIn these like ad spaces where they would put ads. So the data scientist went to a different team besides the product team and plugged in this people you may know feature, and like he had written the algorithm to like determine who people would know. So kind of sideways of the product team deployed this, and then of course LinkedIn's popularity and page views and engagement just skyrocketed after that. So I think it's a good example of kind of the value you can get just by having someone who thinks about the data that you have and how it could be useful. But then a second part is that he actually had a way to measure and test that was effective too. So it's like two-sided. One, he had the idea, and then two, he can measure, wow, this thing really, really worked. A third story, this isn't really a story, but I wanted to touch on the fact that data visualization is a whole, like almost additional field and art and expertise. And it's vastly amazing and complex. So I just wanted to show, like, this is an example of just collecting wind measurements across the country. And that's just a point in a place that you measure which direction the wind is going, but put all that data together and you get something really awesome like this. And this site is really cool too because it has like historical, oh, I'm not connected anymore. It has like historical stuff, so you can go look at like Hurricane Sandy on there, and it's really, really neat. And then there's this other site, infosthetics.com, if you're into data visualization. I don't think I'm connected right now. But this shows like really amazing big data projects. Maybe I'll pull it up after the talk. Awesome, awesome data viz. The New York Times has like an entire 100-person data viz team who all they work on is like how to get meaning out of data points. And my last story is about data communication. It's about the cholera epidemic that hit London. And I think within a day, over 100 people died as soon as it arrived. And it was incredibly devastating. And this guy, John Snow, he had this hypothesis that the cholera was spreading through the water, but he could not convince anyone that this was the case. You guys might have seen this story. There was a TED Talk on it that does a much better job than I will. But basically, he made an amazing data visualization that, in fact, is very, very simple, but was very, very effective at communicating what was happening. He just counted all the deaths that were happening in each building in the neighborhood where everyone was dying. And you could see that there was this concentration of deaths right around this water pump. So this visualization is what it took to convince the city to shut down the water pump, and that killed the spread of the epidemic. So just thinking a little bit about how to take what you know and communicate that data, collect the data and communicate it, can have huge impacts on humans. Okay, now probably everyone here has seen this. It's a lean startup methodology. You build things, you measure how well they're being used or if they're being used. You learn from that, and then you iterate on your design. But surprisingly, a lot of companies don't have the measure part yet. But we have a lot of tools that make it easier and easier now to do that part. And also, when I searched for this also came up, which I don't know what it means, but I thought it was funny. So, and I've gotten the feedback that I need to put more jokes in my presentation. I'm not a funny person. I don't know jokes. I don't know how to tell jokes, but I know a funny image when I see one. So. Kind of like that. So anyway, that's my transition to talk about how to apply analytics to your business. Like, we want to figure out how do we measure things and learn from them. That's what we do with analytics. So this list could probably go on way, way longer, but just at high level, people use analytics to do a variety of things. They can measure their progress toward a goal, whether that's like a number of new users or increasing retention. They use it to monitor health, could be server health, application health, or human health. They use it to test hypotheses, like, will this new feature really increase the engagement with our product? They use it to explore and discover, like, I wonder if there's any pattern in the way that people know each other on LinkedIn. They can use it to support their customers. Like, I wonder what was happening in our app the other day when all these support tickets came in. Like, maybe we can measure what those customers were doing and see what happened. And then you can also use analytics for marketing. Like, LinkedIn did this amazing campaign last year. You guys probably saw it. They sent basically an email to people that was like, you're in the top 5% of LinkedIn profiles. Did anyone get that? Yeah. So it was amazing because it made everyone feel special. I'm pretty sure every active user on LinkedIn got that. But it's just really, really interesting application of data to your business. So now I want to kind of dig into some more specifics for you. Try to think of a goal that you're trying to achieve in your work that you could potentially measure your progress toward it. It's easier if it's related to an app, like an application where you can measure, like collect data. Can anyone share an example? Go ahead.
Let's say customers, you want about 90% of customers to be after a year. But the service
Okay, so customer retention. Okay, and what is, just to dig in a little bit, what does it mean for a customer to be retained? Do they continue to renew a contract with you? Something like that? They pay it. Okay, well, that's a perfect example. Does someone else have another one? Mm-hmm. Okay. Okay. So goal is to increase sales online. And then also like a sub goal is, we're bringing people to the site, how do we improve the conversion of those visitors to shop, to become shoppers? Okay, great, you guys are great at this. So a really common goal, I liked how you guys had business goals. And if you don't have a business goal, another like very simple goal to think about is just engagement. Like, are people using the things that we're building? And these are some common ways that people measure engagement. People creating accounts, people making purchases, posting on Facebook or whatever, making donations or shares. This list can go on and on too. But one thing you'll notice that all these things have in common is that they're all verbs. So the things that you guys mentioned too were also verbs, like fulfilling more contracting hours, putting things in your cart, making a purchase. These are all verbs. So that's my segue to the concept of event data. And event data has many names right now. Some people call it like behavior data or interaction data or even user data. But almost every analytics tool uses event data, and all of those tools use the same format of data. Event data always has these three things. It has an action, like make a purchase or put something in your cart. It has state information, like what object are you putting in your cart, and what's your user ID, and where are you? Relevant things that we know about the state of the universe that's happening at the time of that action. And then every event also has a timestamp. So that's event data. Now the rest of the talk is going to be about what you can do with event data. This is a very high-level concept, but it's very, very powerful. And I think a way to even like further solidify the concept of event data is to compare it to another type of data, which is entity data. So entity data is the type of data that we've collected forever in traditional databases. Your application database has tables where you store things like users, products, nouns, basically. So here's an example of an entity database. We have all these users, We have their first name, last name, what level they're on, and say a game or something. Everything's very neatly organized. We have a distinct number of columns. And we also have information about their organization, but it's like an ID that links to another table where we'll have organization information. So this is the way databases have been designed traditionally. There's only one record for every one entity. It's very neat and organized. It's very strict. And it's very, very efficient for running applications. So contrast that with this type of data, which is an event. Has anyone here played or heard of the game Minecraft? So if you haven't played Minecraft, that's okay. It's just like a lot of other video games, like you can die as a player in Minecraft. And this is an event that models a player death. So let's imagine that we built the game Minecraft. Minecraft, by the way, has like 10,000 downloads a day. The creator of it is probably a billionaire at this point. It's hugely popular. And players can die in Minecraft. They can drown or starve, or an enemy can attack them. There are probably 25 different ways to die. And let's say that as the creator, you want to know what's the most common cause of death. Like you want to make sure your game is balanced so that not everyone who starts playing it just dies immediately. So you want to start analyzing deaths. And I apologize, there's like a death theme in my presentation. Like we had the cholera thing and Brahi, and now Minecraft deaths. But this is a death that captures one player dying in one game, where the cause of death was called the creeper explosion. That's a type of monster that can like walk up to you and explode you. So this is how we would model one death. We have, remember the 3 parts of event data? Can you guys remember them? Yeah, state, time, and action. So the action is death. The time is this timestamp. And here's all the state information. Like what was the enemy? What was his power? Where was it? What was the player level? What was the player inventory? Like this could be really, really big. We might also want to put like what version of the game they were playing. All sorts of stuff. So that's what event data looks like. And imagine 10,000 people are downloading the game Minecraft per day. How many people are dying every day? This is going to be like millions and millions of events that are happening all the time. So just to summarize kind of the contrast between these entity data, or what entity databases were traditionally, and what event data is like now. Entity data has a strict schema, like set number of columns. Event data is very flexible. Like if we had different enemies, we could put in different blobs of data. Like maybe if there's a lava death, we could put in information about the lava. Event data has a flexible schema, just like a big blob of data that you throw out. Entity data is very, very cost efficient for storage. So there's only one record for each person. But in event data, you put information about the purchase on every single event that happens for that user. So it's a lot of repetition, but it captures kind of the state of what it was like at that time. Event data uses a lot more storage. Entity data, like you saw the row in a table, it's short. Event data is wide and nasty. Entity data usually describes nouns, whereas event data describes verbs and things that are happening, things users are doing, things servers are doing. Entity data always captures the current state of your application, like what users do we have right now, what level are they at, what's their age, what type of user are they. But event data describes a trend over time, like what's the number of users we've had for the past 12 months and how has that changed? When you're using an entity database, you update it. So like, for example, if I change my last name, I would just go in and update that record. But in an event database, I would just keep appending. Like, I would add a new event that, like, I did some action today, like I died in Minecraft, and now my name will have changed to be different. But I don't go back and ever update my event data. It's just like a scrolling log of what happened. And then entity data can be big data. Like Facebook, for example, has hundreds of millions, maybe billions of users now. I don't know how many people are on Facebook. So entity data can be really, really big. But imagine if you were tracking every time a Facebook user posted to their newsfeed. That would be like even a multiplier on how the entity data. So event data is really big. And event data is everywhere. So we're just now getting to the point where we can start collecting event data from all sorts of things, not just like web analytics, but car analytics and tractors. Did you know that tractors cost like $1 million now, and they have like the most advanced technology ever? They're awesome. All sorts of things. And one of the nice things is that now we have the technology to kind of handle this, and it's really cheap. It's cheaper than it ever was before. So even though like we've had the concept of event data for a really long time, you haven't really been able to capture all that. Most databases would just fall apart. But now there are tons and tons of options for how to collect and analyze this stuff. And that's why there are lots of analytics companies coming out now, because we've made huge gains in data storage, but then also querying and stuff like that. So the way most services work, you don't use your entity database or your application database to collect this kind of interaction data. You use a different type of database, like a document store or a cloud service or something. Stream events in, and then you can run queries and create, things like dashboards or maybe customer-facing reports, or put stuff on your website. Okay, so I think you guys get the concept of event data. In case you need more examples, here's some other actions you could do. Modify something, post something, play something. And there's all kinds of state info that you could potentially capture on your events. But I'd rather hear from you guys, if you recall your goal from the previous exercise. What's at least one event that you could track to measure your progress toward the goal? Who can think of one? Oh, here. Cancellation. What was your goal? I don't think we heard your goal first. Oh, for his. Mm-hmm. Yeah, totally. Do you guys have some? Oh, go ahead, Sam. Yeah, checkout. Yeah, totally. Mm-hmm. Mm-hmm. So this is a good example of why data science is hard and why it's an art also. There's one way you can do that with cohort analysis that we'll talk about in a little bit. I wanted to kind of, now that we've kind of killed the concept of event data, you guys obviously get it. I wanted to talk about how you apply event data to some of these types of questions. So, common analytics techniques. 99% of analytics, and pretty much most of what I do every day with all sorts of companies, hundreds of companies, involves what mathematical operation? Tally. Counting. Yeah, tally and counting, those are the same. Yeah, amazingly, it's just counting. Like when we set out to build an analytics tool, we thought everyone's going to want to do like statistical stuff and like all this fun math stuff, but like really most people just need to be able to count important things at scale and keep track of it. So that's kind of interesting. It actually makes it really fun to to teach and to help, because once people get it, then they're like all of a sudden totally empowered and go start counting things all over their business. There are some other mathematical operations that I use every day, but they're not hard. Everyone can do them. Like, not just count how many people logged into my app today, but not just count how many logins there were to my app, but how many unique people logged into my app. That's a common thing. And you guys know the rest, sums and averages, and how those would be helpful. What was the average cart size of someone who filled out the cart? There's tons more you can do in data science, and I'm not an expert really in any of these, but you can do in-depth statistical stuff, correlation analysis and predictive analysis. But most people that I work with, at least, and I work with pretty advanced companies who are doing custom analytics, they're not even here yet and don't need this stuff yet. Most of the low-hanging fruit is in counting. Okay, so fancy terms for counting stuff. Here's a simple one, daily active users or monthly active users. It's just counting the number of users who did any kind of engagement or any type of event. Like count the number of unique people who died in Minecraft. Here's an example of Facebook's active users, and they probably measure active users by logging in or loading your news feed or something like that. They have a huge number of active users. Crazy. And then once you have something like daily active users, it's pretty, or monthly active users, it's really easy to do stuff like what was the average revenue per user last month. It's really basic math. It's like the number of unique users in a given time frame, and then you take a sum of all the revenue that you got during that time frame from those users, and then you just divide them. So really simple, count unique with a sum, and now you know the average revenue per active user last month. There's another concept that you might hear about if you're starting to do analytics stuff, which is segmentation, and that really just means grouping people. A common thing to segment on is country, like which country are we getting the best conversion or the most engagement. But there's all sorts of things, like you might have custom things for your app, like where they came from or what type of user they are, what version of your hardware they're using. Filtering is another common concept where you want to filter out test data, or you want to filter out people that aren't in the United States, or it just means reducing your data set down. Okay, so we had a couple examples that you guys provided. Can you think of a property about either the users or the products that you might use for segmentation or filtering? Yeah, exactly. Good one. We do that. I do that all the time. And stuff. Yeah. Whoa, that's cool. Yeah. Yes, that is a very common one. Where did they come from? Another really common use case for event data is A/B testing. So, for example, my event might be press the button. And maybe I want to see if more people press the button when it's green versus when it's red. This is like the first thing that comes up, by the way, if you Google A/B testing. Very common example, but what do you guys think more people would click on, green or red? Everyone always says green, but it's actually red. I think because it just grabs your attention more. But I think we all agree green one looks better. Yeah. Yes. So what's interesting about the data model here is that it's so simple. Pretty much you're just tracking an event when every time someone clicks the button, and then you just have something like a property like color equals red or color equals green. And then you just run a count, like how many people clicked with color red versus how many people clicked with color green. And there are lots of great A/B testing tools now, so a lot of this work is already done for you, but the basis is still just event data. And another common technique is something called funnels, where you have different steps for different types of events, and then you see like how many of your users make it through a certain process. So here's an example of an app like Vine. Has anyone used Vine? Or Snapchat? Either one would work. Okay. So you launch the app, you start a recording, you finish it, and then you upload it, right? So each of these steps is an event that you're tracking, and on it you'll track like which user it was and what version of your app they're using, and then you get this nice funnel. Like it looks like 250 out of 700 actually successfully made it to uploading a video. And then you can identify opportunities like, well, why is it that only 269 of the 500 people who started recording finished recording? Like maybe there's a bug there. Maybe you run two funnels, one with the old version of your app, one with the new, and you see like that they look different. But funnels are just a common way to measure success in kind of a user-oriented way. Another common term is cohort analysis. And cohorts, the easiest way to describe cohorts is to use like a graduating class. So like a graduating class might be the class of 2010 or the class of 2011. And you'll compare them side by side. So cohort analysis is very similar to segmentation, but it's usually referring to segmenting people by a time frame. And then when you look at cohort analysis, usually the timeline part of it is relative. So rather than being like 2010, 2011, 2012, it's like year 1, year 2, year 3, because it's relative for each cohort. So like this looks at what's the performance of a given cohort in the years after they graduated. After year 2, this cohort is here and this cohort is there. So back to your question about retention and when you deploy features, a common way to do that is to say, this is the group of users that signed up in this week when this feature went live, and we can compare them to the group of users that signed up the week before when that, or last month when we didn't have that feature, and you can see which one did better. It's still a little muddy because sometimes multiple features go out and it's a little hard to keep track. So that's one way that people try to group their users. Or you could segment by people who have used that feature or didn't use it, potentially. Yep. Yeah. So that's exactly what we're talking about is retention. And retention is usually just do users keep coming back and doing some action. For most apps, you can think of one action that you use to measure retention, like if it's continuing to buy your consulting services or continuing to put things in your cart. There's usually one simple thing, like the main thing, like with Vine, it would be like watching videos on Vine or something. And once you have that and you track that over time, you can see what the average retention is for your customers, how many times they use your app, when the drop-off is. I think I have an example. Yeah, this is from Mixpanel, which is another analytics tool, and it just kind of shows what a retention analysis might look like by cohort. So I don't think it's super important to dig into this too much, but like I was mentioning with cohorts, you can clump them by like what week they sign up. So the cohort from November 17th, November 27th, et cetera. And then you can kind of see like, oh, this cohort from December 10th, 12% of them are still using our app at week 9. Versus our cohort from November 19th, 23% were still using our app. So for some reason we're getting worse at retention in this example. I wonder why. Maybe we shouldn't have released those features. Or maybe the people that we marketed to November 19th were just way, way higher value customers. Churn is the same as retention. Once you know retention, you know churn, so that's just a different math that you do, but churn is just a percentage of your users that you lose. And if you have like especially if you have a recurring revenue business model, it has a huge impact on your business. So if you Google like churn, you'll find this, and it's pretty huge. Even like small numbers, like 2% difference in churn has like huge difference in your ongoing revenue. And then just sharing a couple more formulas. Customer lifetime value, once you know your average monthly revenue, which you can, if you're capturing every purchase, you can say, what's the sum of every purchase, of all the purchases for each of the past 12 months? And then you can get your average monthly revenue, and then divide that by the number of customers, so your monthly revenue per customer. You can multiply that by your profit margin, and then once you know retention, your average retention, now you know customer lifetime value. So again, it's all basic math. It's counts, multiplication. It's not rocket science. Okay, and then finally I wanted to just sum up with like ways that we do data science. Like there's so many different tools, and these are just a few of them, but just to give you an idea of like what do we actually do with this event data. One thing is you could create dashboards for your team to kind of measure performance in real time every day. You might pull data into Excel and, thank you, you might pull data into Excel and slice and dice and find some segment of users that you really want to talk to. I love Excel, I still use it every day. You might use more advanced stuff like Tableau, good for data visualization. This is what Keen.io looks like, just query building. on your events. There are lots of other tools out there like this too. You could even use your own event data to provide value back to your customers. This is what one of our customers built. It's like call center analytics, and they built the whole interface so that their customers can see how many calls are happening each day. And, sometimes you can think about, well, how is our data useful to our own customers? It can be an asset for your company as well. And then sometimes you just have to write scripts to crunch data and munge it up with other stuff. And a lot of data science is writing code too. So that's a little bit about event data. Hope you found it helpful. Was it helpful? Okay, that's good. If anyone has any more questions or wants to talk about their business in particular, I'm happy to do that. Or questions now are fine too. Sure.
One thing I hear about a lot is the risk of these powerful data scientists from powerful companies where you can tell me a little bit about how to be careful with where there's data scientists. Not drawing wrong conclusions. Just some people see patterns of anything.
Yep.
Especially like top graph code that
Yep. So it's interesting because I work at a data company and we don't even call ourselves data-driven. We're very like intuition-driven, but we use data, but we are like very cautious about it. We're like, this is what we know and these are some facts, but like we still rely on our instinct a lot. So there's that aspect. Like I would never say like we only make decisions based on data because you know there's a certain level of error in the way you think about it most likely, right? So there's that, like just use caution. And then it comes down to trust too. Like, do you trust the person that is running the data? Are they just trying to make themselves look good, or are they trying to make your organization successful? One of the things that's interesting about data is you can make it tell whatever story you want. You definitely can do that. But it's like, if you want the organization to succeed, then you're not going to paint a rosy story when there isn't a rosy story.
Yeah, just it becomes so cheap. Like you said,
yeah.
Everybody has access to it, like everybody starts taking pictures.
Yep. Yeah, it's like, are they acting in their own interest though, or are they, that's like the important question for any company, I guess. No easy answer there. Did you have a question? Oh.
So these techniques, so I think that in digital work, you need to apply now to analysis.
Mm-hmm.
What about non-digital work that they use and you be applying to that segment analysis?
Well, it depends. So in one way, a few ways I can think of, yes. Like every time that there's a transaction at the cash register, that's an event. So you can have all that data. We already know that Target and Walmart are amazing at this. They can predict that someone is pregnant and is going to need diapers in like 12 months or whatever. So there's that data analysis. And then, is that what you mean, or do you mean like in-store retail stuff?
I think propensity versus event. It seems like you have ability in digital work to do some kind of entry prompt or gathering data that kind of analysis on top of that. But in retail world like Walmart and Target, do you see that that same model is being applied or being useful? Or
Yeah.
are you having the capability to do that?
Definitely. I would say that they are pioneers in this space. Okay. Yeah. Yeah. Yes. And I would say that Walmart and Target probably have entire data science teams. Yeah.
So what
Yeah.
would be an event example like you can Walmart or
Like you were talking about adding to a card or what takes the right of into your card, what geography are you from?
Yep.
How many items in the card? You put one TV and you put a million household items.
Yeah.
All these things. What pages you look at, where you might go from.
Yeah. So
Anything you click or do, there's a recording of it and it gets put in a database like you said, and the database just grows exponentially until somebody gets around to combing through it and drawing conclusions.
and the model in physical retail space would be basically the cash transaction. Like when you finish a purchase, we can record what store you're in, what you bought, were they on sale? What color of thing did you buy? Like that state data can be really big in retail. And then, yep, exactly. And then there's like creepy stuff too. Like I've heard about like people like tracking, like they have cameras and they can see like where you go in the store. So there's like, I mean, I don't know if that's creepy, but it's definitely interesting. And that's like another type of data too, where your action is, I don't even know if that would be event data because you're like kind of always going. It's more like a user flow. Yeah. Oh, you're welcome.